This is Precalculus, chapter 5.2, one-to-one functions, inverse functions. Let's get started. For number 14, you see that every domain matches up with one exact range. So yes, the function is one-to-one. For number 16, you see that two of the domains matches up with one range. So this is more like a 2-to-1 function. So we want to answer no, the function is not one-to-one. For number 18, you see that all the domains matches up with different range. So yes, the function is one-to-one. For number 20, you see that all the domains matches up with its own range. Yes, the function is also one-to-one. For number 22, we can use the horizontal line test to determine the function is one-to-one. So here we are. You draw a bunch of horizontal lines, and you can see that each horizontal line intersects the function at only one point. So yes, the function is one-to-one. For number 24, let's bring out the horizontal line test. All I need is one horizontal line, and you can see that there are 2 points of intersections. So you can say that no, the function is not one-to-one. For number 26, so if you draw the horizontal line test, you're going to see that two lines are overlapping, which means that there is going to be infinite many points of intersections. So here you're going to say no, the function is not one-to-one. For number 40, let's go ahead and find out if f of g of x equals to x. So let's go ahead and insert the square root of x plus 2 into g of x. So you get f of square root of x plus 2, and let's insert the square root of x plus 2 into the x. So you're going to get square root of x plus 2 minus 2, square the whole thing, cancel out the plus 2 and minus 2. You get square of square root of 2, which equals to x. So you want to say yes, they are inverse functions. For number 44, I'm going to use a different way to verify their inverse functions. So I'm going to erase the f of x. I'm going to write y. The inverse function of f, you can swap the position of x and y. So I'm going to go ahead and rewrite it as x equals to y minus 5 over 2y plus 3. I'm going to go ahead and multiply by 2y plus 3 on both sides. So it cancels out, distribute the x. So 2xy plus 3x is equal to y minus 5. Subtract 3x on both sides and subtract y on both sides. So these are canceled, and I have 2xy minus y equals to negative 3x minus 5. Factor out the y, so I have y times 2x minus 1 equals to negative 3x minus 5. Now here, continue from the last step, I'm going to divide it by 2x minus 1 on both sides. So now y is isolated. Y is equal to negative 3x minus 5 over 2x minus 1. Right now they look kind of similar, but they're not exactly the same. So what you want to do here is you want to factor out the numerator and denominator by negative 1. So it's going to look like this. Negative times 3x plus 5 over negative times negative 2x plus 1. You can switch the position of these two. So this will become 1 minus 2x. And the negative and negative makes it positive, or you can see that the negatives are just canceling each other out. So now you can rewrite it without the parentheses, and now they're identical. So they're inverse functions. For number 46, if you swap the x and y of this point, nothing changes. So you're still going to get a negative 2, comma, negative 2. If you swap the x and y of this point, you're going to get negative 1, comma, 0. Swapping this, you're going to get 0, comma, 1. Swapping the 2 and 1/2, you're going to get 1/2, comma, 2. So let's just go ahead and connect all the points. And this is what you got. And this is the inverse function. For number 48, let's go ahead and swap these two. And you're going to get positive 1 comma negative 2. If you swap these 2 points, you're going to get negative 1 comma positive 1. For this part, it looks like this. But for that part, it looks like that. And that's the graph of your inverse function. For number 50, let's go ahead and analyze this part. This is what you're getting for that part. And for this part, this is how it looks for the inverse function. For this part right here, this is how it looks on the inverse function. The last part, straight line, this is what you're getting. And this is the graph of your inverse function. All right, that's it. Take care. Good luck with your homework.